Okay, now really, if you haven't tried this page without watching this video, stop the video, because this page is so much like the last page, it's not even funny. So we're looking at the cosine graph, which is also, no, not 1-to-1, right? Same reason as before. It's just a shift. But our previous domain restriction from negative pi over 2 to positive pi over 2 is bad. Right? So is the same restriction we previously used appropriate for finding an inverse cosine function? Whoop. No. Doesn't give 1-to-1 function and doesn't hit entire range. Those were our two requirements from before. Let's go back and take a look. Numbers 1 and 2 did not take the full range of -1 to +1 because it just went from 0 up to 1, which is bad. We lost half of our y values. Not only that, it doesn't hit, it isn't 1-to-1, right? The upper loop failed the horizontal line test. So we, these two guys right here, these two non-negotiables for creating an inverse function, those failed. We were just trying to center it around 0, but remember that centering it around 0 was just a nice thing to have if you could. Doesn't look like we can center things around 0 for the cosine function, because when we're at an x value of 0, we're at a maximum. We can't go both ways. So let's just go one of the two ways. And which way should we go? Probably the positive way. If you have a choice, you'd probably pick positive, right? So that would be your nice to have. So that's why we pick a new restricted domain of 0 to pi. That fits the first two non-negotiable requirements, and then it's all positive, which is kind of nice. This creates, now we've got the same idea as before. We've got the cosine inverse, inverse cosine, and we've got the arc cosine. Those are interchangeable. They mean the same thing. When we graph this, remember that we swap the x's and the y's, so we used to have 0, 1, and we used to have pi, -1. Well, when we swap them, we get 1, 0, and -1, pi. And remember, we also had that nice point in the middle, right? This point right here is pi over 2, 0. So now we've got 0, pi over 2. So those are 3 points that we've got. Remember that this used to be at maximum, farthest to the top. Now it's a farthest to the right. Tops and rights kind of switch. So we kind of curve like that, and then we also curve like that. And that's a 1-to-1 inverse function that hits all the values of the range, the original range of -1 to +1. Okay, let's put that there. The original range was -1 to +1. Now we saw what happened last time. We just swapped. So the range of this old function becomes the domain of this new function, right? -1 to +1. And the domain of the original function that we restricted now becomes the range. We go from 0 to pi. So that's our arc cosine function. Same deal as before. We're going to say, well, what is the value that when we take the cosine of it, we get 1/2? Same deal as before. We're going to get a lot of answers. This time, the first time x equals 1/2 is when we go up to here, right? At pi over 3. So pi over 3 is one answer. And then we go down to 2 pi over 3, which is -1/2. So we don't want that. And then we go down to 4 pi over 3, which is also -1/2. We don't want that. But eventually, we'll get around to 5 pi over 3, which is another solution to the equation cosine of x equals 1/2. And again, just as before, we can continue around the circle, and we'll get 7 pi over 3, and more positive values if we go in the counterclockwise direction. And we could also go in the negative direction to find an endless list of coterminal angles that all satisfy this equation. But that's no good, because we've got an inverse function, the inverse cosine function. So we define that to be in this range right here. Our answer has to be between 0 and pi. And the only answer to this equation down here that exists between 0 and pi is the value pi over 3. That's the one and only answer. No other answer is acceptable. And once again, we'll go through the other ones kind of quickly. The cosine of an angle equals negative root 2 over 2 at 3 pi over 4, which again is only one of the many answers to the equation, but the only acceptable answer to the value of this expression. Cosine equals negative 1 when we get to a theta value or an angle value of pi. And then, just as before, we can't take the arc cosine of 2 because 2 is not in the domain of our function, so does not exist. Undefined. Don't waste my time with a question like that.